So solving trig equations, there are two basic identities that you got to be aware of, and here they are. I put them at the front of the video so that if you need to reference them, you just rewind back to the beginning of the video. One thing is that we also have, not one thing, but the fundamental identity, cosine squared plus sine squared equals 1, allows us to trade cosine for sine, or vice versa. We can use either of these to change our identity for cosine to look like 1 minus sine squared x minus sine squared x. That would be using the first one. Or we can substitute for sine squared x, and we get cosine squared x minus 1 minus cosine squared x. So 2 cosine squared x minus 1, or 1 minus 2 sine squared x. Any of these three is available for cosine 2x. Okay? But sine 2x is just 2 sine x cosine x. Alright. Okay. So this equation says we want to find solutions in 0 to 2 pi. So the first thing to pay attention to is what they're asking for in terms of the answers. And the other thing to pay attention to is the fact that I have two different arguments for the trig functions, which necessitates that I use an identity. And so we're going to go to, whoops, that's not the color we want. We want 2 sine x cosine x minus cosine x equals 0.
Yeah.
Generally speaking, at this stage, we want a factor. Maybe we'll have a quadratic. In this case, we don't. We have cosine x times 2 sine x minus 1 equals 0. If we had a quadratic, we'd want to get it all in terms of one or the other. But this splits up into cosine x equals to 0, or 2 sine x minus 1 equals 0, which is sine x equals 1/2. Okay? We're asked for answers in 0 to 2 pi, which means it's unit circle time. If I'm looking for cosine x equal to 0, that's the x-coordinate equal to 0. That happens here and here.
Yeah.
So that would be x is pi over 2, and x is 3 pi over 2. Now, sine of x equals 1/2. That's the y-coordinate equal to 1/2. That's going to point us to this spot or to this spot.
Yes.
And our knowledge of the unit circle tells us that this angle right here is pi over 6.
Correct.
And this angle over here is 5 pi.
Over 6.
Over 6. In other words, pi minus pi over 6, right?
Yeah.
So that tells us that x is pi over 6, or it's 5 pi over 6, and if I want to put all of it together, that tells me all of the solutions to this equation in the interval 0 to 2 pi, which corresponds to starting here at 0 and going around 1 time. Okay. So for this one, we're actually asked to find all the solutions. And we notice that we have a 2 theta, which would tempt us to use a trig identity. But there's no need because there's no other cosine or sine
Yes.
in the problem. So there's no need to get their arguments matching, right?
Would you then just add the radical 3?
Sure,
Both
sure.
sides? Yeah.
So now we just go straight to cosine 2 theta
Is equal to
Equal
radical
to
3 over 2.
root 3 over 2. Now we're going to find all the solutions, but the first thing we have to do is find the basic solutions, the fundamental solutions, you might call them. Cosine being radical 3 over 2 happens when x is radical 3 over 2. And that's going to point us to, I'll call this pi over 6. And we could call this other angle, we could call it negative pi over 6 if we wanted. Or let's call it 2 pi minus pi over 6, which is, what, 11 pi over 6?
Yes.
Okay. So we can, at this stage, we could say that 2 theta equals pi over 6 plus whatever multiple of 2 pi we like. 2 theta could also equal 11 pi over 6 plus whatever multiple of pi that we like. Now, our goal is to solve for theta.
Yes.
So we can just divide both sides by 2.
Yep. And that would give you 11. Oh, or we're on the bottom or the top?
Top.
Yeah, that's pi over 12 plus n pi.
Right.
And there you have 11 pi over 12 plus n pi.
Okay. Good enough.
Good enough.
So this one, I guess, did they specify? Yes, they did. They want the solutions in 0, 2 pi. Okay.
So we get everything on one side.
Right.
So 2 sine squared u equals sine u minus 1. Plus sine u. Oh, sorry. Yeah.
There we go.
I lost my
Okay.
ability to read.
Yeah, you said equals also, and you meant plus. But it's
Yeah.
fine.
Yeah.
Let's factor. Can we factor? One thing to do is you could just say something like s equals sine u if you insist on making it easier to read. Factoring, we know we have a 2s and we have an s. Now the question is, we want the plus 1 over here to beat out the minus 1 because we want a plus right here in the middle, right? Anyway, 2s minus 1 equals 0.
Yes.
S equals 1/2. S plus 1 equals 0.
S equals negative 1.
S equals minus 1. Okay, so what we really want is sine of theta equal to 1/2. We actually already did that earlier in the video. That was these two spots.
Yes.
So star produces x equal to pi over 6 and 5 pi over 6. And double star here corresponds to the y-coordinate equaling -1, which will produce x equal to 3 pi over 2. All right. Good enough. All right. New wrinkle on the situation, which is we have to know that tangent is sine over cosine. So this is 2 sine t over cosine t.
I love it.
And secant is 1 over cosine, so this is 1 over cosine squared t. Okay.
So we need a common denominator.
Exactly.
So you can just
we'll multiply this by cosine. It looks like an exponent, but hopefully we can figure out here. So this is a cosine, but it goes there. It's not an exponent. Anyway, 2 sine t cosine t.
Yes.
Minus 1 over cosine squared equals 0.
Yeah, isn't 2 sine t cosine t the same as saying sine of 2t?
Sine of 2t.
Yeah.
Exactly. Sine of 2t minus 1 over cosine squared t equals 0. Okay. Now, in this equation, because it's an honest equality and we're not doing the weird inequality stuff, we only care about the numerator equaling 0.
Yes.
The denominator gives us a restriction.
Yeah.
Okay? So we need sine 2t minus 1 equal to 0 and cosine squared t not
equaling 0.
0. Okay? Sine 2t minus 1 equals 0 tells us that sine 2t is 1. We have to look in 0 to 4 pi for answers because of this 2 here. You remember that little wrinkle?
Yes.
On things? If we want our answers to come from 0 to 2 pi, that refers to t, not to 2t. So 0 to 4 pi on the unit circle is 1 time around, 2 times around. We want sine of 2t to be 1. That happens here. That means 2t is going to be pi over 2. Or 2t is going to be 5 pi over 2. Agreed?
I agree.
So this tells us that t is pi over 4, or t is 5 pi over 4. And it's a simple matter to check that cosine squared of pi over 4, which would be this business right here. It's actually going to be root 2 over 2 squared, which is 1/2. It's not 0, so this one's okay. And cosine squared of 5 pi over 4 actually would be this one over here, which is negative root 2 over 2. Still not 0. So both of these solutions check out. Okay? And there you have it. T is pi over 4 and 5 pi over 4.
Beautiful.
All right. As we proceed through the levels of difficulty, we are now encountering something quite difficult. Tangent 2x equals tangent x. Sine 2x over cosine 2x equals sine x
over
cosine x. Okay. Step 1, we got to do the identities. 2 sine x cosine x over, I'll just use cosine squared x minus sine squared x equals sine x over cosine x. Okay. Let's cross multiply. 2 sine x cosine squared x equals sine x cosine squared x minus sine squared x.
Yep.
Okay. It is tempting to cancel the sine x. We can't do that. Because if we just canceled it and forgot about it, we would be excluding the solution sine x equals 0.
Yes.
So I'm going to be careful, but you could cancel sine x and say, I'll do that in like very light yellow or something. You could cancel sine x and just say sine x equals 0 as one of your solutions and carry out the rest as it is. I'm going to instead do this. 2 sine x cosine squared x minus sine x cosine squared x minus plus sine cubed x equals 0. So I distributed and moved it all over to the left side.
Mm-hmm.
Agreed?
Yes.
All right. So 2 sine x cosine squared x minus sine x cosine squared x is sine x cosine squared x plus sine cubed x. All of that equals 0. Right? Factor out a sine x, and a miracle occurs because what we're left with is
1. And then, well, yeah.
Right? And I wanted you to see that miracle.
And sine x is 0.
And so that means sine x has to be 0,
Exactly.
which is what we have over here in yellow. So that tells you sine x has to be 0.
Yeah, and that's a good way to make sure.
Um,
the way that you know what you just did.
Okay, so in the end, this is a silly way to write the number 1, which leaves us with only sine x equal to 0. If I'm looking between 0 and 2 pi, this thing happens right here and right here, which means x equals 0 or pi. Okay? So in the end, we can actually go back and think about the original equation. How is it possible for tangent of 2x to equal tangent of x? Remember, tangent is a slope.
Yes.
And so this is telling us that the slope of an angle 2x equals the slope of half of that angle, which is x.
Mm-hmm.
How could that possibly happen?
Yeah.
Except x equals 0 or x equals pi. Okay.
Absolutely.
All right.